fractions, you have to have common denominators. We all agree on that. 2/3 plus 4/3 is 6/3. We've done that. In this instance here, my denominators now may or may not have variables. They might be expressions. They might be trinomials. They might have separate terms. Remember when I'm calling terms, I'm talking about like x minus 2, x plus 3, things like that. So we still have to make sure that those denominators are the same. 4 over 3x plus 5 over 3x. Do they have common denominators? Yes. What is the common denominator? 3x. So when you set that up, you get 3x for your denominator, and what's your numerator? 9. Can you do anything there?
Yes.
Yep, we can simplify it out, but they're both divisible by 3, and your final answer would be 3 over x. Again, it's the same basic scenario as you guys did before. As long as you had a common denominator, you could add the numerators together. The denominator stays the same. Does it work the same with subtraction? Yeah. These guys have a common denominator. It's x plus 3. So now what's 2x minus 4? Good. Now, you guys might notice right away that there might be something you can do with 2x minus 4. What could you do to that? I could take out a 2. Now, the reason why I'm asking you guys to just take a second to look at that is sometimes you might be able to simplify something further. Like we did here in that first example, you guys were able to take out a 3. In this case, if you take out a 2, you wind up with x minus 2 over x plus 3. Did it really get us anywhere? No. So my suggestion, always look at your numerator just to make a quick double check if there's something else that can get simplified out. You will find from time to time it does occur. There's no magic reason why, it just kind of does. Right. The weird stuff then, obviously, is when you don't have the same denominator. So think about what you did when you didn't have the same denominator when you first learned, before they gave you a calculator. What did you have to do? What are we getting then? What is this called? What do you have to get? Least common multiple, what they call it, the LCM, the least common multiple, or the greatest, or the least common denominator, or whatever you want to call it. A lot of times you guys were able to find that by just multiplying the two numbers together. In this case, I can do that because 3 and 2 both go into what? 6. If this happened to be 4 and 6, if I multiply those two together, I get 24, correct?
Yeah.
But isn't there a number smaller than 24 that would work? 12. So you always want to look for the smallest value. It's just a little bit easier to work with. If you use the larger one, it's not the end of the world, but you'll have to simplify later. You might get messed up somewhere along the line. So in this case here, with the 2/3 and 1/2, you guys all agree that the denominator would be a 6. What did you have to multiply the first fraction by?
2.
Over what?
2.
Because what you're doing here is, what is 2 over 2?
1.
1. On the other one, you had to multiply it by 3 over 3, which is also known as, remember when we took care of conjugates, we took care of rationalizing denominators, we're always multiplying by factors of 1? It's the same thing stemming from fractions. All you're doing is just changing the shape. That's it. You're just bending it a little bit. So you wind up with 4 minus 3. Okay. What's going to change when we have polynomials? Really nothing. Not a lot. What's going to change here? Oh, we just did that one. What's going to change here is that we have to worry about common denominators. And in order to be able to figure out the common denominators when you have polynomials like this, you're going to have to factor. You're going to have to factor everything that you can prior to finding your denominators. And this takes a little bit of getting used to. So let's see here. We have 5 over 6x squared that 6x squared, is there anything I can factor with that? Not really. There's nothing I can do there. So I'm just going to write this out in a couple extra steps. What can I do with this denominator? Take out the 4x. And what are you left with? Everybody agree with that? Now, solely look at the fraction on the right. Is there anything you can do to that? I can get rid of the x's, can't I? Everybody see why I can do that? No. See how this is 4 times x times the quantity x minus 3? It's 3 things being multiplied together. The numerator has a single x. That means these two can simplify out because it's a grouping of 1. So now what happens here is that I'm able to simplify that a little bit prior to getting my common denominator, just a little bit less work. Sometimes it happens, sometimes it doesn't. It kind of works the same way if this happened to be a 2x up here. I could have simplified the 2 and the 4. Sometimes you're able to do that with the x values as well, as long as it's straight out written up as multiplication. All right? So now I know that my new fangled addition problem is 5 over 6x squared plus 1 over 4 times x minus 3. From here, I need to figure out my common denominator. What you always want to start with is the numbers. What's the least common denominator of a 6 and a 4? You're thinking common factor. When I should say it's multiple. What's the next number that we both go into? 12. Good. So I know that the common denominator between a 6 and a 4 is going to be a 12. Now that I've taken care of the numbers, all I have left now are things with variables. This side has an x squared. This side has an x minus 3. To get the common denominator, what do you think I have to do to them? You said it. Multiply. So it's going to be 12x squared and then x minus 3. What we just did was take care of the numbers. That's the easy part. We've been doing that since 4th grade. I don't know what it is. Then, what does each fraction have? One has an x squared, one has an x minus 3. You multiply them together, and it's common. It bears the same resemblance to the 3 and the 2 in the denominator. You multiply them together, therefore it's common. Okay. So now, after that, you just start asking yourself some simple questions. In order to turn the 6 into a 12, what do you have to multiply it by? 2. So I know right away I have to multiply the 5 by a 2. This has an x squared. This has the x squared. This doesn't have an x minus 3, so what should I multiply it by? Bless you. What I have done here is basically multiply the top and the bottom by what it was missing to turn it into the common denominator. And I'm going to do that again with the next fraction. This guy has a 4 and an x minus 3. It's a plus sign, so I've got to make sure to put this up here. It's plus 1 times, 4 times what is 12? So I put a 3 here. And it has an x minus 3, but it's missing the... I've now multiplied together all the parts that it needs in the numerator to be able to put this thing together.
Why is the 3 in parentheses?
What's that?
Why is the 3 in parentheses?
I'm just showing that it's multiplying. That's all.
Just get rid of it.
You can. It's fine. I just did it because the 1 was already here. If this was like a 7, I'd write it as 7 parentheses 3x squared just because it's how I write it out. That's all. Now, the last bit to worry about then is just kind of simplifying out your numerator. Everybody agree that this 5 times 2 is 10? 10 times x is? 10 times negative 3 is? So I have 10x minus 30 plus what? 3x squared. All over 12x squared x minus 3. Don't multiply out your denominators. go through it, okay? Always go ahead and multiply out your numerators, because you'll notice here, we just combine some like terms. And sometimes you might be able to come across something that can be factored. You might be able to take out a 2, you might be able to take out an x, something like that. If I look at this, it's basically the same thing as saying 3x squared plus 10x minus 30. Can you think of anything that you multiply together to get 90, negative 90, that adds together to get 10? 9 and 10 doesn't get you. 3 and 30, no, that's not get you there. Nothing, so you can't factor anything further. You're done. Okay. To be honest with you, what I'm showing you guys here to start with is kind of like the toughest way it's going to look. I wanted to overcomplicate it to begin with. Let me show you something that's a little bit cleaner than your 5 pickup. All right?
This problem is incredibly simple.
It's not as complex as yellow.
Yeah, definitely.
Again, as you write out the problem, what should you be doing right away? Simplifying, not simplifying, but factor it as you're writing it out. So I have x plus 1 over, what would that be? X plus 2, x plus 2? Minus 2 over so right now we're sitting at that. What's that? Why? It's not multiplication. Okay? They're not ones in the numerator, denominator, it's subtraction. Do either of those denominators have anything in common? They have an x plus 2 in common. Do you guys agree? So right off the bat, I know that they both have an x plus 2. Since they both have an x plus 2, and I'm going to do a little trick. Just going to block one out. I've already accounted for the common terms of x plus 2. What's left?
X plus 2.
And I write it down. If you think about what you're doing with this, when you have denominators, again, of that 6 and the 4, if you write it out in terms of prime factoring, 2 times 3, 2 times 2, they both share a 2. We wrote it down. What was left? A 3 and a 2. 2 times 3 times 2 gave us 12. It was creating the least common denominator without having to multiply everything together. You're doing the basic same operation here by prime factoring, if you will, by just factoring out your denominators, writing down whatever they have in common, and then whatever's left over. And that accounts for everything. Okay. So now when you go back to the fraction on the left, oops, move this out of the way. The fraction on the left already has 2 of the x plus 2's, but what's it missing? So what do I have to multiply the top by? X minus 2. And what's the other one missing? It has an x plus 2. It needs one more. This denominator already has x plus 2, x minus 2, but in order to be common.
Top is 2 times.
Oh, okay, I'm sorry. I misread you then. Again, what should we do with the numerator? Yeah, multiply everything out, combine like terms in your numerators. Leave the denominators alone. Yes, sir.
Why, we just cross off the like top and bottom so we didn't know?
What's in the middle of that numerator?
Minus.
So can I do that? Another puppy just died.
Ooh.
So your final answer would be x squared minus 3x minus 6 all over and I can't factor my numerator any further. Sometimes you might be able to, sometimes you won't. In this case, there's nothing to multiply to get negative 6. That'll add to get negative 3. Okay. Yeah. Yeah, if you wanted, or this came up before, if you want to write it as quantity x plus 2 squared, that's fine. It's not a big deal. It's really not that big of a deal. Then, it's just about a factoring and just going through that. We use this a lot more tomorrow with solving of equations. All right, do this one then. So everybody agrees you have a common denominator, x minus 4, x plus 3. Okay. What is a fraction on the left missing? So we have x. What's the fraction on the right missing? Everybody agree with that? What's the last thing you gotta do? Just distribute out and combine like terms.
You can't do that. I mean, I know it's just all the subtraction. I knew it. It was in my head, but it was,
Right there.
Derek kept whispering things like, cross it out. Derek, shut up.
That evil little thing.
I don't think he sees it.
How did you do that? Oh my god.
That's great. That's awesome.
What happens when you do a triangle?
One star.
Oh!
Whoa.
Illuminati, that's the real Illuminati.
Wait.
Wait, that just.
What?
Oh my god.
I was thinking it did not.
What?
I,
Do
you
that
can't
again.
tell me nothing.
Michael, so easily engaged.
Oop.
It's no homework.
Says who?
Says the
Oh,
magic.
oh, and it's gone.
Thanks a lot,
Oh,
Illuminati.
So your final answer is
Bring it
no.
back. So wait.
That guy's
What?
I was excited.
No homework.
One thing that I'll tell you guys when you're going through these, your denominators really aren't going to change throughout most of the process. So as soon as you figure out what your common denominator is going to be, you don't have to continuously write it out each time, which is fine. In this case here, I always worry about my numerators. I'm always going to try to FOIL things together, distribute, combine like terms, whatever I have to do, because I may or I may not come up with something I can factor again. Once again here, I've got what times what's positive 24 to get negative 3? Nothing. And I'm done. Don't worry about multiplying out your denominators. There's no reason to. Okay? All right, so let's scare you.
Oh boy.
Oh, what?
That's not fair. Okay.
I just understood.
This is called a complex fraction.
Can we put a fraction on top of the fraction?
Sure. Welcome to the Wambulance. You guys whine about everything. It's just the Wambulance. I'm trying too hard at it.
Yeah, you're trying to class smart.
A for effort, though.
I try my best.
Too hard.
It's fine, I'm just putting it on the sheet of paper.
Oh,
Can I have it?
What this is what we call a complex fraction. This is nothing more than a really nasty looking fraction. If you think about what this is nothing more than the following.
I can't even draw. This is difficult to draw.
It's the same thing as 2/3 being divided by 4/5. It's a vertical representation of a division problem
Yeah,
of fractions.
There's X's.
Oh, I know.
Yeah.
Don't worry.
I'm worried.
Don't worry. Now, if you wrote this out like this, if I wanted to rewrite that horizontally, how would I write that? Yes, sir.
Is it 2/3 times 5/4?
Very good, very good. You just skipped out. I was looking for the next thing. 2/3 divided by 4/5, otherwise known as 2/3 times 5/4. This
Oh, so-
complex fraction turns into a nothing more than a multiplication problem. But in order to turn it into that multiplication problem,
You get to do this.
I gotta get the common denominator. I gotta get rid of this addition problem between the two fractions of the denominator. Okay? Notice there's nothing to worry about in the numerator here. I say that mockingly, but it's just 2 over x plus 2. You know, nothing else you can do. There's no factoring, there's nothing to take out at all. So I'm gonna look at that complex denominator, the 1 over x plus 2 plus 2 over x. If I'm looking at just that, is there anything that I need to worry about factoring here and here?
Nope.
So what's the common denominator?
X squared plus 2x.
Okay, you're making it more complex than it needs to be. Can I just write it as,
That's not Oh yeah, that's straight out the gate.
well, you were right. There's nothing wrong with that, but it's just a little bit easier to see it this way.
Gotcha.
Okay? What I'm doing here is I'm getting the common denominator for the whole nasty looking problem to start with. Because in order to do this, by the time I come around to dividing and multiplying by reciprocals, I'll be able to make this a lot easier to work with. So again, the fraction here on the left, the x plus 2 part, what is it missing? So I multiply the top by, so I have x. Can I write 1x if I want? Doesn't matter. Now I have plus 2 times, what's that side missing? X plus 2, very good.
So this is all on the bottom.
This is all the bottom.
1/2 is
Yeah, so what does this become? So this is x plus 2x plus 4, so it's 3x plus 4. Do you agree? Over x. So right now, I'm going to rewrite this to the division. We didn't have to touch anything in this first numerator. So we have 2 over x plus 2 divided by 3x plus 4 over x times x plus 2. Now it's the exact same problem that you did yesterday. And like Willis already showed us, he figured out that when you're dividing the complex fraction, it's multiplication, and it winds up being 2 over x plus 2 times x and what drops out?
The x plus 2.
Yes, the x plus 2 goes away.
X goes up.
Ah, can I get rid of the x here?
There's no one.
I can't because there's an addition again.
So it's 2 plus
And you're done. It starts out really nasty looking in the beginning,
gnarly.
but all you have to worry about is which one of the top or the bottom of the complex fraction really needs any common denominator work. You work with that part first, and then you start going by the multiplying by reciprocal. Okay? Let me give you one. One of these. Try that. Now, be careful. You got to do something in the numerator and something in the denominator here. All right, let's see how we did. Obviously, the common denominator in the top is 5. Does everybody agree?
Yeah.
Okay. So if you do that, you get something over 5. You get x plus 20.
Hey!
Hey!
Wait.
Common denominator and the bottom, x.
Yeah.
Do you get 8x plus 1?
Yeah.
Okay, now the tricky part. X plus 20 over 5 times x over 8x plus 1.
How do you do this?
How do I do this? Oh,
That's
Kidding, I know how to do it.
because there's nothing I was going to be able to simplify. If you were going to be able to simplify something, you would have been able to pick it out right there from the multiplication part.
That's what's strong.
Since you can't, there's no reason to write it out any further than that. It's not a big deal.
So if it ends up like that.
Yeah, that's what you're
Yeah, that's fine. That's fine. Yeah, if you wrote it out as x squared plus 20x over 40x plus 5, it's not a big deal. It doesn't help you anything. Once you get into these complex fractions like this, if you notice right away when you go ahead and multiply, if nothing simplifies, there's no real reason to multiply anything out. Does that make sense? Not as scary as you thought. What?
not bad.
Well, you are. Besides the point.
Yeah.
Let me give you some problems. Sure about that? Section 9.5. This is page 565.
I mean, officer said, I got all of the sheets.
Sense and calming presence, guys.
You're not an artist.
You did turn beet red though. That was pretty funny.
You haven't read it though.